find the exact value of cosine of alpha minus beta, given that the sine of alpha is 1/3, the cosine of beta is equal to negative 1/3, and that both angles are in quadrant 2. Well, we have a little bit of a problem, right? It gives us the sine of alpha and the cosine of beta, so I'm going to need the sine of beta and the cosine of alpha in order to solve a difference with my cosine. So what am I going to do? Well, the only relation that comes to mind right off the bat is that sine, oh, that's really thick, sine of alpha, sine squared alpha, plus cosine squared alpha equals 1. So what can I do? Well, I can substitute in, I know what the sine of alpha is. It's 1/3. I'm going to square that. I'm going to add the cosine squared alpha to it, so that's still 1. I'm going to solve for the cosine squared of alpha. So that's going to give me 1 minus 1/9. And if I simplify that, that gives me what? That just gives me 8/9. But if I just want the cosine of alpha, that means I'm going to have to take plus or minus the square root of 8/9, which, hey, that comes out to something kind of pretty, right? It gets plus or minus 2 square root of 2/3. But I have a little bit of information, right? It says it's going to be in quadrant 2. So if it's in quadrant 2, cosine has to be what? Well, it has to be negative. So that gives me that the cosine of alpha is negative 2 square root of 2/3. Okay, so I've got one of them. Now I need to find the sine of beta. So I can do this again. I've got sine squared beta plus cosine squared beta equals 1. And in this case, I don't know sine. That's what I'm looking for. I know cosine. It gave me is negative 1/3. I'm going to square that. I need to just solve for the sine. So that's going to equal to 1. Now this right here will simplify to 1/9 again. So I'm going to need to subtract it from both sides. And that's going to give me 8/9. So I get that then the sine of beta, I have to take the square root of both sides. And that simplifies once again exactly to the same thing I had before, which is 2 square root of 2. That's kind of funky looking, over 3. Now, it said that the sine is also in quadrant 2, and what do I know about sine in quadrant 2? Well, in quadrant 2, it's positive, so I'm just going to have 2 square root of 2/3. So we did all that work. Now, how in the world are we actually going to use that? Well, if you recall, the cosine of alpha minus beta is the cosine of alpha times the cosine of beta plus the sine of alpha sine of beta. Now, some of you may have wondered, why didn't I do that first? I didn't because I remembered that the cosine of that already equaled this. Now, if you didn't see that and now you're asking yourself, why didn't she do that first? Then you should do that step first so that you understand that is why we had to find the cosine of alpha and the sine of beta. And with those now, this is just simply a plug and chug. So I've got minus 2 square root of 2/3 times minus 1/3 plus 1/3 times 2 square root of 2/3. And when you do all of that crunching, it simplifies down to 2 square root of 2 plus 2 square root of 2/9. And that has one more simplification, right? I can add those on top. So that's going to give me 4 square root of 2/9. So that's going to be your exact value. So remember, do not enter that in the calculator.